Go at it. This is Mark Nelson from New South Wales, and he's going to be talking about death.
Thanks very much, Brian. So it's good morning from New South Wales. Let me throw out a good afternoon or a good evening as well to cover all bases. First of all, I'm not going to use differential equations to predict when you're going to kick the bucket. That's not the aim of the talk. The aim of the talk is to use differential equations to estimate when a person has died. And perhaps the underlying question motivating this presentation is, can students in a second year applied maths subject successfully use the skills they were taught in a first-year statistics subject? And I think most of us are going to be able to predict the answer to that question. All right, so here's an exam question that I've used in 2020 and 2021. So what we want to do is we want to estimate the time of death. We want to estimate the uncertainty in our prediction. And then we want to use these numbers to see what we make of the statement that the person who found the body is made. All right, so I know that these days a lot of people like to use real numbers as part of their modeling. These are not real numbers, they're numbers that I've made up. So I solved the equation, I got the exact answers, and then I subjected them to some perturbation. So things that I would like to know that I don't know is, when a body is found and the forensic scientist comes in and they make measurements, what's the time frame over which they make the measurements, and what's the real uncertainty in the measurement? So if anybody has any pointers on that, I would like to hear, because I would like to make these numbers more realistic. But yes, let me just reiterate that no student was harmed during the process of getting these numbers. All right, so here's the question. Now, I didn't just bring this question onto the students in the exam. That would have been a bit too much. So it actually followed on from a question that had been on an assignment earlier on in session. And in the earlier assignment, they'd constructed the mathematical model, they'd solved the mathematical model, they'd applied it to some data. So this was intended to be a relatively, they should already have had the skills to answer this question successfully, and hopefully they were going to pay attention to the what does the answer mean part of the question. So I'll just recap what they did in the assignment. So the second half of this subject is on heat transfer. So they'd learn how to apply a heat balance. And so they applied a heat balance to a dead body. They developed the heat balance into a differential equation. They solved the differential equation. They rearranged the differential equation in order to massage it into the form of a straight line. And then they could use what they know about linear regression that they learned in the first year. Now, in order to make things slightly easier for them, we assumed that the ambient temperature was going to be fixed and not changing. And we assumed that the initial body temperature was accurately modeled. And so we were just interested in estimating this parameter lambda. And once we've estimated the parameter for lambda, we can derive a formula that tells us when somebody died, because we know the body temperature when somebody dies. So this was all information that students had when they entered the exam. The exam was an open book exam, so they had all this information already. They didn't need to rederive it. And so the exam question had different data than the assignment question. And the assignment question just said, estimate the time of death. There was no interpret the answer. That was the new thing for the exam paper, interpret the answer. What does it mean? So just a little bit about the background for the students in this subject. This is a second year subject that's called mathematical modeling. almost all of the students taking this subject are doing a mathematics degree, and occasionally there might be 1 or 2 students not doing a mathematics degree, but if they are, they're doing a science degree or an engineering degree with a lot of mathematics. This first year subject is not formally a prerequisite for this second year subject, but the way that our mathematics degrees are structured, it's pretty difficult to do second year subjects without having done this first year subject. So I can assume that students have done this subject. That there is a small number of students who haven't taken this subject, those students have got to teach themselves what they need to know about linear regression in order to answer this type of question. So between 2020 and 2021, I've had 36 students reach the exam. Of those students, 34 of them have attempted to answer this question. What can go wrong? Given that we have all this inbuilt information on how to answer this question from the assignment, what can go wrong? Well, let me first ask the question, how did students do on this question? Perhaps a bit of a spoiler alert, but I did change a few things in the subject in 2021 as a consequence as to what happened on this exam question in 2020. All right, so if you do the linear regression correctly, you can find the time of days and you can estimate the uncertainty in the time of days. And this information is inconsistent with the statement that was provided by the person who found the body. And at the end, I want to turn to the question as to how did students address this inconsistency in their written statements, because I think that raises some interesting issues. All right, this is my kind of refrain throughout the talk. What can go wrong? All right, so the numbers in blue are the students who got the correct answer, which were 6 of them. And these are all the other student answers. And we can see that there's quite a wide range of answers here. The ones in red are students who got an answer that's within the standard deviation of the correct answer. So on that count, approximately half of the students, or in fact, exactly half of the students got an answer that was in the standard deviation of the correct answer, but half of the students have made predictions that are woefully incorrect. Why is that the case? How can students go so badly wrong applying linear regression when they've already learned that technique in first year? Yeah, so what can go wrong? What went wrong? All right. Yes, I'm not going to, originally I was going to do everything in the logical way and go through it carefully, but I want to show this figure immediately because this is something that I found shocking. I was shocked by this when I started to look at the answers. All right, so there's various little steps that you've got to go through. You've got to transform the data. You've got to take log of the transformed data. You've got to plot it. And a few students did that all correctly. They used Microsoft Excel to plot the data. I don't care what software packages students use. They're free to use whatever package they like. And this is the figure that they got. This is a correct figure. You can see the data points. You can see the scattering the data points. And here's the answer. And what's wrong? So students haven't done anything wrong. They've done everything correct. They've put it into, they've done the calculations they needed to do. They've put it into a regression package. The regression package has got the answer. This is all correct. But what's wrong is this value for the gradient that Microsoft is giving you because it's only accurate to one significant figure. And this is going to mean that when they calculate the time of death is not going to be correct because they don't know the gradient to sufficient numbers of significant figures. So it's not an error that the students have made, it's an error that the package has made. Yeah, so yeah, I found this very interesting. All right, so what went wrong? We're going to use linear regression. So 3 students went wrong because they decided, let's not use linear regression. And so what 2 students did is they rearranged the equation that they found. And they saw, well, we've got 6 data points, but we've got 5 data points when t is not equal to 0. We could just use the data points to estimate the value for lambda, and then average these estimates for lambda. Yeah, that's what they did. We need to calculate the transformed variable correctly. 2 students couldn't do this. We've solved the differential equation. We've shown that if you rearrange it, you can manipulate it to get a straight line. So we want to plot log z against t. But 4 students ignored the analysis they'd already done and decided they should plot temperature as a function of time instead. And this was very unfortunate from my perspective, because it turned out that this actually gave a very accurate answer in this case. So they got good answers that they didn't deserve to get. That meant that they didn't get many marks, even though they had the right answers, because the method was incorrect. On this answer here that's slightly larger than the other answers, this is due to errors in, no, not errors, but this is due to the regression package that they used, rounding the estimates for the constants in the straight line fit and not giving them to large enough numbers of significant figures. Okay, so talking about rounding, one student did everything correct. They got the Z values correct. They put the right information into their regression package. They used their regression package correctly. The regression package did give them the right information with the right number of significant figures, but the student decided to round those numbers off before doing the calculation. Now, I suspect that what happened here is, there's a lot of talk in the class about when you get your final number can't be more accurate than the data that you've used to calculate it. I think what the student forgot here is that when you do intermediate calculations along the way, these intermediate calculations are allowed to be more accurate than the data that you're using. So I think here the students got confused and they rounded off a number that they shouldn't have round. And in this particular case, maybe it's not made a big difference to the estimated time of death. It's what, 14 minutes. But potentially that could be important. And then 2 students went wrong. They did everything correct. They got the right values for the gradient, for lambda, but somehow they made a mistake when they calculated the time of death. And 1 student had an error that I couldn't quite work out what the error was. So, that's right here. Again, they got the right answer for the regression line, but somehow they managed to get the wrong answer from that. All right, so 3, 5, 9, 10, 13 students went wrong along the way. Let's just have a quick recap. So I've got 36 students doing this question in an exam over 2 years. 2 students chose not to answer this question. 13 students made errors along the way. That meant that 21 students did everything correctly. So 21 students should have got the right answer. But I already mentioned that only 6 students got the right answer. What's happened to these other students? All right, so I already showed you this figure, so I'm going to go back to this figure because I just find this figure astonishing. So here they're using the Microsoft Excel trend line, and the Microsoft Excel trend line is not giving the answer to the right number of significant figures. And I did talked to somebody who uses Microsoft this year in 2021. That's right. I was aware of this problem. So when we did the question in the assignment, I talked to some students about this, and some students know that they can change there's something that they can change in Microsoft so that they can get a more accurate answer. But yes, yeah, I'm still almost lost for words for this error coming up, that students are getting something wrong, but they've done everything right. It's the choice of regression package is not giving them the answers to the significant number of figures that's required. So just to continue on this theme, so here's the right value for the gradient. So 2 students use Google Sheets, and so they got this. I mean, it's not, in this case, it's not a very big difference. It's only a 1 minute difference, but I mean, the point is that the number of significant figures is rounded. 3 students used, got this answer here, where we can see that the gradient's been rounded off to even fewer significant figures. And 5 students used the Excel trend line that I've already mentioned that only give 1 significant figure. One student still went wrong somewhere, and they should have got 396, but they didn't. That's 10 students. So there's still a few students whose errors I've not accounted for yet, but yeah, I'm a bit concerned that these regression packages and students can't control the number of significant figures, and maybe they don't know how to control the number of significant figures. Oh yes, and another student, everybody else was using minutes, but this student decided to use hours as their time scale. And again, they didn't get enough significant figures here, but it's only a 2-minute error, so perhaps not so bad. All right. So what are my conclusions? Well, what I want to, yes, the exam question had 3 components. One component was estimate the time of death. We can see that not many students managed to do that. The second question was estimate the uncertainty in the time of death, and very few students could do that, despite the fact A, they've done a statistics subject, and B, there were questions like this on the assignment. So very few students estimated the uncertainty. And then the third part of the question was, how do you reconcile your estimates of the time of death with the information that the witness provided? And I guess here I'm not really criticizing the students directly, because they haven't they haven't done these kinds of interpretations before. But I think that this is perhaps something that's interesting to investigate in future. So I would just say that the evidence that the witness provided is inconsistent with the numbers that we created, whereas students went a lot more further than that. The witness is lying, or they're even implicated in the deaths. These are very strong statements to be making from the evidence that's provided. I mean, I guess this is almost perhaps touching on issues of professional integrity in terms of how strong the statements are that students are making in terms of what the evidence is. Now, since using this question, I have had a couple of thoughts on different things to do. So one thing that I have in the back of my mind is to change the question slightly. So the scenario is that the student's acting as a scientific advisor to a legal team, and they've got to write their answer in a form that would be appropriate for that. And the second thing I've been thinking about is that in Wollongong, we do have a law faculty, and in their teaching, they have a lot of like situations when students go into a mock court and present arguments and look at evidence. And I'm wondering if there's some scope here for some kind of question for the law students to do when they're given one of the incorrect analysis of the data as part of the evidence that's presented to them. and then whether the law students accept this incorrect analysis at face value, or whether they go off because they know students who are doing maths degrees and get them to check the analysis. That might be something interesting to explore. One of the students, so in Australia, we've been locked down, or at least in New South Wales, we've been locked down for a large amount of time. And students are obviously thinking about the COVID test and the fact that you run a temperature when you're taking a COVID test, or you can do. And one student made the interesting observation that if you had a fever when you were murdered, then your body temperature would be different. And this would affect the estimate of the time of death. And so I'm just wondering how I could try and massage this into a question to provide some extra information to students that they would then have to take into account. I've not got a handle on that, but I think that would be an interesting thing to do. Oh yes, what would Jane Austen say or write if she was alive today? Perhaps if she was an academic, she would say that it's a truth universally acknowledged that students in the second year of a degree have forgotten everything that they were taught in the first year of their degree. Oh, yes, I did change a few things before between the two instances. And is it fair? Is it fair to ask a question in a second year subject that requires students to know what they were taught in first year, when that subject's not officially a prerequisite for your subject? Yes, and yeah, this is one of my main takeaways. The packages that students are using to do these regression calculations are not producing enough significant figures. So if you only remember one thing from this presentation, this is the figure to remember, and the fact that there's only one significant figure in that value for the gradient. And it only remains for me to say good morning, good afternoon, good evening, and if I don't see you again, goodbye.
Well, thank you very much, Mark. Can you leave that figure up just a second? Is when people started using technology, one of the cynical criticisms was, how can you trust your answer? And do the students have enough savvy to do a reality check on the answer? This is a case where to the right of 2 is that coefficient minus 0.0002. We're missing some of those digits. And those digits are critical to what we're doing. And yet the tool doesn't immediately, unless you know the trick to say, give me more digits, the tool doesn't immediately give that back. And so your students went down that rabbit hole and you couldn't really fault them. But is this not a case that the faculty has to really scrutinize the software they're using a little more, because these things can happen? Is it our fault, is what I'm asking?
I think that was a good, I've written that word down, savvy, because that's, I might use that when I write this up for a paper, because that is a good word. So just before I answer that question, if you just look at the raw data and how quickly the body is cooling down, you can use that to go backwards to estimate when the person died. And some students did that as a way of then checking that the computer calculation was in the right ballpark. So, but those kind of students who do that are the students who are doing physics or engineering degrees, and the math students don't do that kind of calculation. Now, I don't know why this problem about the digits hasn't turned up before. I think it's probably just a fluke in the numbers that I've used for this particular calculation, that it's at the limit. It's the limit at which the package will give you the answer, because if you had numbers, and the answer was 0.1234, you'd have plenty of digits there. So I think it's not been noticed before at my institution, because it's just unlucky that the digits in my example give rise to this problem.
Okay, yeah, I've been in meetings where statisticians have torn apart Excel for any number of issues. So this is just one nuance which can go the wrong way for students. Any other questions before we get set for Stuart's presentation? Okay.
I've certainly seen this part of Excel. I would suggest also giving some interpretation problems first in an assignment, not on an exam, so that you can tell people if you think they're off track. When it isn't an exam, they will take it in probably better.
Yeah. While we're talking, Mark, would you unshare your screen so
Sure.
Stuart can do that? Okay. And Deb's right. You know, you give them a couple of heads up experiences before you throw them into the den.
Right.
All right. Thank you again, Mark. Very much appreciated, and acknowledge your distance, and yet you're right around the corner.